Hello, class. Good morning to you. I'll wait about one more minute and then get started. All right. Actually, I'm going to start after I finish this banana. One more bite after this. Cool. So, what we've been doing for the past few weeks, aside from the IA, is we've been learning about various libraries, APIs that are non-standard, not a standard part of the Java language, and seeing some of the cool things we can do with them. So for the next, I think, 3 or 4 lessons possibly, we are going to be learning a little bit about some math libraries, some more advanced math libraries, and also some scientific computing libraries. So if you didn't know, I'm also the physics teacher on campus, and so I have particular interest in these things. So I wanted to learn them, and I wanted to teach them. So that's what we're going to be discussing for the next few lessons. So what we are going to, so the sort of the jar file that you need to add to your class path is found here. So you would do a Google search of Apache Commons Math, and then to download the relevant jar files, you would just download the zip or the tar file, depending on what kind of machine you're running. And then I'll show you. So this is the folder that you'll get. Click on that, and it has some documentation, and it has a bunch of jar files. And the one that has all the stuff that you need for these assignments is Commons Math 3 3.6.1.jar. So if you look at Genie here, under my build commands, I have added to my class path Commons Math -3 Commons Math 3 3.6.1.jar, and then under my execute commands I've put the same thing, and then I've also added the current folder. Okay, So that is how you will run this code. So if you click along the side here, there's the documentation. Now, when I was trying to get this to work, I accidentally made the mistake of clicking latest API docs, which it says is development. And so the issue with that, let me just click it and I'll show you what it says. Let's open a new tab. So if you look at that, see how it says Apache Commons Math 4.0? But if you look at what you downloaded, is you downloaded Apache Commons Math 3.6. So this has all the wrong import statements. Okay, see how this says, if you wanted to include the class abstract curve fitter, you would have to write a line of code that says, org.apache.commons.math4.fitting.abstract curve fitter, but that's not correct because you downloaded Math 3. So that took me a long time to figure out, but I figured it out. So if we look at abstract curve fitter here, this is the correct documentation. It should be Math 3. All right. So you want to make sure you click the Java doc for the 3.6.1 release. Okay. So what does Apache Commons Math do? It does a lot of things, and so you can see in the user guide here kind of just a sample of what it does. So it does statistics. I'll just kind of focus on the ones that we're going to look at today. It does statistics. It does curve fitting. Okay. So those are the two that we're going to look at today. All right, so let's go ahead and go to my code. This should be a fairly quick, straightforward lesson today. So I have two parts. The first part is for the curve fitting. All right, so I'm going to uncomment this part of the code. All right, so there's a class in this API called weighted observed points. Okay, and so what that is essentially a list of data points. Okay, so basically what we're doing in this statement is we are creating a list. I should say an empty list to hold data points. Okay, and then so that weighted observed points object is called obs for observations. Okay. So then I have obs.add, and then I have the x coordinate and the y coordinate of a particular data point. Okay. So so basically the format is dot add x coordinate comma y coordinate of the data point, and you can do that for as many. So repeat for however many data points you have. All right. So in my case, this would be a great place to have a loop. So you loop and add the data points. All right. So let's try to visualize what are these data points that I added. All right. I added the point 0, 0. I added the point 1, 1. Okay. I added the point 2, 2. And my last one was almost 3, 3. But I can see that the y coordinate is a little bit more than 3. Okay. So, so basically, the data points added are almost, and I say almost because they're not exactly because of this 3.2, from the equation y equals x. Not quite from that equation, but almost. So I'm going to write that in the form of, you know, like the y equals mx plus b form. So basically you can see, so m equals 1, b equals 0, approximately. But it won't be this exactly because we made it 3.2. All right. So now there are different curve fitters that the Apache Commons math could do. So for example, you could do an exponential curve fit. You could do a sine or a cosine curve of best fit if the data is going up and down. So there are different model functions you can use for the curve fit. But we're just going to keep it simple for today's lesson and do a polynomial curve fit. Okay, so you can see there's so basically this line of code, so the polynomial curve fitter class is kind of weird. It like doesn't have a constructor. Instead, what it has is a static method. So the polynomial curve fitter class has a static method called create, which returns a polynomial curve fitter object. Okay, so I'll put a comment under this. The above line of code creates a polynomial curve fitter object using a static method. And notice how it says create 1. All right. So that means that it creates a first degree polynomial curve fitter object using a static method. So what do I mean by the degree of a polynomial? So a 0th degree polynomial would be an equation of the form y equals a0, where a0 is a constant. Okay. A first degree polynomial is y equals a1x, a1 times x plus a0. A second degree polynomial is going to be y equals a2 times x squared plus a1 times x plus a0. Okay, so the degree of the polynomial is the highest power of x, and then the if you have an nth degree polynomial, you have n plus 1 coefficients. So a2, a1, and a0, okay, are the coefficients that the curve fitter is going to try to find for your particular set of data, okay? So let me just write that down. An nth degree polynomial has n plus 1 coefficients, okay? The curve fitter determines which coefficients best match your data. Or I should say best match the points you added. Okay? So why did I do a first degree polynomial curve fitter? Well, that's because the data points that I added are almost from the equation y equals 1 times x plus 0. Okay? So that's a first degree polynomial, right? Because the highest power of x is 1. And so for my data, I expect a1 will be approximately 1, because a1 is the number that multiplies x to the first power. And I expect a0 equals 0, because a0 would be b. All right, and I can see that b is 0. So that's what I'm doing. That's what I'm trying to accomplish with this. But the point is that if I just had I'm just doing a very simple example of the points that I've added to show that it works. But if you just had, 500 random points and there's noisy data and you want to find the line of best fit, this will do that. So the data points that I've chosen to put into the curve, or to add to the data set, are very simple, and so it's easy for us to understand what the line of best fit should look like. But if we had hundreds and hundreds of data points, this would work as well, even when we can't sort of intuitively guess what the curve of best fit is going to look like. Okay? So yeah, so this is a very simple data set where we can easily identify the curve of best fit. Okay, so then I have a double array called coefficients. So basically, coefficient 0 is going to be a0, and coefficient 1 is going to be a1. All right? So I should have just called it a. I'm going to call it a, just to be consistent with what I wrote up here. Okay? So we take our polynomial curve fitter object, which is called fitter, and we call its fit method on. I just realized that I was not streaming for a second. I'm not sure if, because I was looking at the Genie screen, I wasn't looking at my upload rate, which I normally look at while I'm talking. So I'm not sure how much was just lost there. Someone type into the chat so I know. Okay, I'll come back in a second to look at that. Okay, so basically what I'm doing is I am calling the fit method, fit data method, of my curve fitter object on my set of data. Okay, so that's what I'm doing. Oh, okay, cool. So you didn't lose that much. All right, and so now what I'm going to do is I'm simply going to print the coefficients, and I have to change this because my coefficients were renamed to A. So what we expect, so I'm just iterating through the list of coefficients, and I'm printing the ith coefficient, okay? So I start out with a 0, and I end up with a, and then so it's going to print out a 0, and then it's going to print out a 1, okay? So let's compile this. Okay, compilation finished successfully, and then let's run it. All right. So what you can see here is, here's the output of the program right here. And the first line is going to be the 0th coefficient, which was the b value, okay? So the 0th coefficient is the one that multiplies x to the 0. And we can see that it's negative 0.0399, okay? That's really close to 0. So notice how b is really close to 0, as we expected, okay? But the reason it's not exactly 0 is because we have this 3.2 here. And then our slope, right, the slope is a 1 because the slope multiplies x to the first power. And we can see that that is approximately 1, okay, which is what we expected. In fact, we can see that it's a little bit bigger than 1. And the reason for that is because this number right here is slightly greater than 3, so it pulls the slope of the line of best fit up a little bit. It makes the line of best fit a little bit steeper. Okay, so that is an example of how to use the Apache Commons Math to do a curve of best fit. Now there is a second part. So one of the so I'm going to comment this again. Comment this out. Whoa, what's happening here? So I'm going to comment out this portion of the code. And then we'll focus on the second part, which is easier, actually. So so there's a class called descriptive statistics. So this line of code creates a new descriptive statistics object called stats. Okay, so what the descriptive statistics objects do is they take in a bunch of data points. So in this case, it's not ordered pairs that it takes, but it's just numbers. So for example, test scores, okay? And then okay, and then it can compute. It has various methods where you can compute statistics that you might want. Okay, so then what I do is I have a for loop that's going to run through 200 values. 200 times is how many times it's going to run. And then I have stats.add_value to the list, okay? So basically, and because I'm adding math.random, this line of code is going to add 200 random numbers between 0 and 1, okay? And then I can print to, so I've added all those, and then system.out.println is going to do stats.getStandardDeviation, okay? So output the standard deviation of the data set. If you don't know what standard deviation is, it's a standard deviation is a measure of the spread in the data, okay? So we know that the standard deviation is going to be less than 1 because the full range of the random numbers is between 0 and 1, so you can't have, actually it's going to be less than 1/2, okay, because, yeah, but I won't go into the statistics of that, don't worry about it. But it's just a measure of the spread of the data. And you know what, I also want to output the average. Is going to be stats dot, I believe it's get mean. I'm going to double check that that's what I actually want to call. While I'm doing that, tell me, what do you think this will output? If I have a bunch of random numbers, 200 random numbers between 0 and 1, what should this output? So think about it while I look up whether it's get mean is the method that I want to call, and type it into the chat if you know what that should output. Okay. Let's see. I want to look for descriptive statistics. Can even get the kurtosis. Sweet. Kurtosis is a measure of how skewed the data is. Okay, yeah, so I was right. So there's a get mean method of the descriptive statistics class. Cool. Let's see if someone typed it in. Okay, looks like, oh, okay, cool. You are correct. So it should output 0.5, okay, because the numbers are randomly appearing between 0 and 1, so the average should be in the middle of that, okay? So let's see if it works. I need to get a new computer. This is so slow. Boom. Okay. So again, there's two lines. The first line is the mean, which we can see is right around 0.5. And then the standard deviation. So that's basically measuring how far approximately are the points deviating from the mean. And we can see that that the standard deviation is about 0.3. So what that means is that most of the points are within 0.3 of the mean. Okay, so that's kind of what the standard deviation is saying. And that makes sense, okay? The standard deviation couldn't be greater than 0.5 because that would mean that most of the data points are greater than 1 or less than 0. They're outside the range of the numbers, so that would be impossible. Cool, so that works as well. Now, what I want to point out here, I just want to go up to the import statements. All right, so you can see that I used essentially 3 objects from the Apache Commons Math library. The first was weighted observed points. The second was polynomial curve fitter. And the third was descriptive statistics. And so for that reason, I have 3 import statements where I'm importing weighted observed points, polynomial curve fitter, and descriptive statistics. How did I know that this was the import statement for descriptive statistics? Well, what you want to do is you want to go into the documentation and you find the class that you're working with along the side here, so descriptive statistics. And see, it says class descriptive statistics, and then it gives you sort of its inheritance architecture, or its inheritance, this is like its family tree, okay? So the in Java, the basic, every single class inherits from the class called object. And then the class descriptive statistics directly inherits from object. And I can see that that's the import statement. Okay? So basically what you're going to do is you're going to copy that. And that's exactly what I did. I just did Control-C and copied it. And then did import and then pasted that line of code. Okay? So I hope that was interesting. I hope you can see the utility of that. And so I have a fairly easy assignment where you are going to do a second-degree polynomial curve of best fit. So that would be a parabola to some data points that are input by the user. Okay, so I will see you in the Zoom room for some more discussion.